So you're diving into machine learning, and you keep hearing these terms thrown around: supervised, unsupervised, reinforcement. It's easy to feel like you've missed a key lecture somewhere. Well, today we're going to clear that up. By the end of this, you'll have a really solid mental model for the three fundamental ways that a machine actually learns. So how does a machine actually learn? The word learn itself can be a little misleading. It's not like how we learn. A machine doesn't just absorb information from a book. Instead, it uses a few very distinct strategies to get smarter. And the real question is, what are those strategies? Okay, here's the most intuitive way to think about it. Imagine you have three different kinds of teachers, and each one has a completely unique teaching style. If you can understand these three teachers, you'll have the key to understanding how most of machine learning really works. So here's our game plan. First, we'll meet the teacher who gives you an answer key. Then, we'll look at the one who asks you to find your own patterns. And finally, the teacher who lets you learn through trial and error. After that, we'll talk about how to choose the right one for your problem. All right, let's meet teacher number 1. Think of this one as a supervisor training an apprentice. This is by far the most common approach you'll see in the industry. It's called supervised learning. With supervised learning, we give the machine a data set where every single piece of data is labeled with the correct answer. It's kind of like giving a student a practice exam that comes with a full answer key. The algorithm's job is to study the questions and the correct answers, learning the patterns between them. The whole goal is just to get really good at predicting the right answer for new data it's never seen before. Now, supervised learning usually tackles two main types of problems. The first is classification. This is about predicting a category or a label. For example, is this email spam or not spam? The second is regression. This is all about predicting a continuous number, like what's the future price of this house? So one gives you a category, the other gives you a value. To do this, people use a whole toolbox of well-known algorithms. You'll hear names like linear regression, which is great for finding straight-line relationships in data, or decision trees, which make predictions by asking a series of simple yes or no questions. We're not going to dive deep here, but just know these are the reliable workhorses for supervised tasks. Now for our second teacher. This one isn't a supervisor. They're more like a detective. They hand you all the evidence, but no answer key. This is unsupervised learning. So with unsupervised learning, the machine gets a dataset with absolutely no labels. No correct answers are provided. The goal isn't to predict a known outcome, but to explore the data and find hidden structures all on its own. It's exactly like giving a detective a box of evidence and just saying, find the connections. The algorithm has to find the signal in the noise. This approach is perfect for tasks like clustering, which just means grouping similar things together, like sorting customers into different segments based on their shopping habits. It's also used for finding associations, like when a system learns that people who buy bread also tend to buy milk. And it's really critical for anomaly detection, like spotting a fraudulent transaction because it just looks different from everything else. But the main challenge here is pretty clear. Without an answer key, it's really hard to measure accuracy. You can't just check if the model was right. Instead, you judge its success based on how useful or interesting the patterns it discovers actually are. Our final teacher is an explorer. This one learns by doing, by interacting with an environment and seeing what happens. And this is reinforcement learning. With reinforcement learning, we don't even start with a data set. Instead, we place an AI agent inside some kind of environment, usually a simulation. The agent learns by taking actions. Good actions that get it closer to a goal earn a reward. Bad actions get a penalty. It's a lot like training a dog with treats or just learning to beat a video game through trial and error. This whole process is one continuous feedback loop. The agent takes an action, it observes the result, it gets feedback in the form of a reward or penalty, and then it updates its own strategy. It repeats this loop millions of times, slowly learning the best policy for what to do in any given situation. But what's really key here is that the agent isn't just chasing the next immediate reward. It's learning to maximize its total reward over the long term. This means it might make a short-term sacrifice if it knows it will lead to a bigger payoff down the road. It's learning to think strategically. So we've got our apprentice, our detective, and our explorer. How do you know which one to hire for the job? Well, it almost always comes down to two simple things: the data you have and the problem you're trying to solve. Let's just lay it out. If you have labeled data and you want to predict an outcome, that's a supervised task. If you have unlabeled data and your goal is to discover hidden patterns, that's an unsupervised task. And if you need a system to learn the best series of actions through interaction with an environment, that's a job for reinforcement learning. A classic example of supervised learning is your email's spam filter. It was trained on a massive dataset of emails that humans had already labeled spam or not spam. It learned the patterns, and now it applies that knowledge to your inbox. For unsupervised learning, just look at a product recommendation engine on a shopping site. The system doesn't know in advance what you'll like. It just clusters you with other shoppers who have similar buying habits, and then suggests items that group has also bought. It discovers those customer segments all by itself. And for reinforcement learning, a powerful modern example is the AI in a self-driving car. It often learns in a simulation where it's rewarded for safe, efficient moves like staying in its lane and penalized for errors. After millions of simulated miles, it develops a robust strategy for navigating the real world. So if you're going to take away just one sentence, make it this. Supervised learning maps an input to a known output. Unsupervised learning finds groups within the input data. And reinforcement learning finds the best actions to take over time. Ultimately, the most important takeaway is that your data dictates your approach. The kind of data you have or don't have is the single biggest factor in choosing which of these methods to use. It all boils down to a few simple questions. Do you have an answer key? That's supervised. Do you need to find the underlying structure in your data? That's unsupervised. Do you need an agent to learn through interaction? That's reinforcement learning. So the next time an AI recommends a movie or navigates you through traffic, just ask yourself, which teacher was at work? Was it the apprentice with the answer key, the detective finding patterns, or the explorer learning by doing?